Okay, so we're talking about what is an algorithm. We saw this as an example. So an algorithm is a step-by-step procedure for solving instances of a well-defined problem. So a well-defined problem is find the greatest common divisor of two numbers. So that's a well-defined problem. It's clear what we're trying to do. So I can't think of an example of a not well-defined uh, problem. Or find all good people in this room. Okay, that might be considered not well defined because it's not clear what good is, what good means. Okay, so it's hard to say whether someone is actually good or not. So that might be an example of a not well-defined problem, but this is a well-defined problem trying to find the greatest common divisor. And solving instances, instance means this is the algorithm, um, but the algorithm is used for particular instances. And by particular instance, we mean, for example, when we say A equals 10 and B equals 12. So that would be a particular instance. Okay, some examples of simple problems. Integer multiplication. So we're going to talk about greatest common divisor next, but another example is integer multiplication. So you take this number and you want to multiply it by this number, and you need to come up with an algorithm for doing that. So you might know, I'm sure you know such an algorithm because you can do it by hand, right? So you take 6 times this digit and blah, 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 all those things that you do. So you could write that down as an algorithm, okay? And this would be an instance of it, right? Because we have two specific numbers that we're trying to do it for. Integer multiplication is the general algorithm, and then we do it for a particular instance. Okay, greatest common divisor, we just talked about that. What is the largest number that divides exactly each of two inputs with zero remainder? In other words, Euclid's algorithm for GCD is shown at the right. It works for all instances of GCD. In data processing terms, it works over all inputs. So no matter what inputs you put in here, apparently this algorithm will work. For example, 18 and 15, the answer should be 3. The greatest common divisor of 18 and 15 is 3. A flow chart, that's this thing here, shows the stepwise flow of data in an algorithm from top entry to bottom end. Here in the greatest common divisor, data flow is indicated by the arrows, so we were following the arrows. Arrows connect single steps in the algorithm, so we go from this step to this step, so we have only an arrow from one step to another. Can you follow this flowchart? Well, I guess we followed it. Okay, so let's look at some of the details of this because you see that there are rectangles here, there's this kind of shape here, there's this kind of shape, like a diamond shape they call it. Why do they use those shapes? So parts of an algorithm, part 1, our chart for greatest common divisor contains various shapes and arrows. As we mentioned, the arrows indicate the flow of data between the steps. Data flows from the top, where data is input, so here we input the data, to the bottom, where the answer is printed here. The shapes in between represent so-called atomic or individual steps in our algorithm. There are two basic types of steps. So atomic means like basic. Okay, it's individual, indivisible steps. Okay, there are two basic types of steps. Operations on data, operations for control of data flow. So let's see what that means. Operations on data, most rectangles. So most of these rectangles are operations on data, but not all of them. So data input and output, that's considered an operation on the data. So here we have a rectangle for data input. Here we have a operation on data, printing it out. That's data output. That's also a rectangle. Okay, data transformations. Here we're transforming data. We're taking B or B and subtracting A and making that the new B. So that's a data transformation. And data storage. Actually, this might be also referred to as data storage because I'm storing something new in B. In VB, these are expressed as statements. Can you find the points of data transformation? How is the data stored here? So we just went through that. Can you find any rectangles that are not operations on data? So for example, this goto is not an operation on the data. Okay, operations to control data flow. So forks are decisions or tests. So these are diamonds. These are called forks because you can go either this way or that way. Okay? Notice the yes-no decision at each diamond. In Visual Basic, expressed as decision structures. These are called decision structures because you're making a decision. You're saying is b equal to 0? That's a kind of we call that a decision. So we're either going in this direction or in that direction. Can you identify the tests in this chart? So they're the two diamonds here. Cycles. So this is also operations to control the data flow. And the cycles are repeated operations or flow loops, expressed here as go-to statements. In Visual Basic, expressed as loops containing tests. Can you identify the loops and tests in this chart? So for example, we have a loop, basically. We go back to here and we ask this question, and if it's and then we have a decision here. Okay. Okay, you can easily carry out this algorithm by hand, so we just did that. Or instead you can ask the computer to do it, but how are we going to get the computer to do this? We're going to have to express this algorithm in a programming language in order to get that done. Just express the algorithm as a program and provide input. Learning how to do that well is exactly what this course and all computer languages are all about. Okay, so let's look at some typical problems in data processing. In practice, problems in data processing often appear more abstract than standard problems from arithmetic. So if you compare these, like finding the greatest common divisor, it's a little bit more than just doing a simple arithmetic operation. They also correspond to complex real-world problems involving discrete math, maybe. Nevertheless, arithmetic and algebra are frequently involved. So there are problems involving decisions. Given any here's an example. Given any login attempt, determine if the password is correct. So we have to decide whether, when someone tries to log in, whether the password is correct or not. Sort. Here's another example. Sort all input integers by size comparison. One sorting algorithm shown at the left is called the bubble sort. So you have to do a lot of comparisons, and that means decisions, like is A greater than B? If it is, put it in front. If it's not, put it in the back, whatever, and so on. Problems involving optimization, another type of problem that we do in data processing and programming. Find the cheapest order of visits to deliver a product to M cities. So you have to deliver a product to M cities, or you have to travel to M different cities. Like suppose we have to travel to Tokyo, Fukuoka, Oita, and Kyoto. So what's the cheapest order or the shortest order or something like that to travel from Tokyo and visit all of these cities and say, come back to Tokyo. So again, you're going to have to do checking. So you're going to have to check lengths, distances. So you're going to have to say, is this length less than that length, and things like that. So it's a decision. Problems involving generation. So we want to generate or show, produce the set of prime numbers from 1 to n. So given n equals 1,000, generate or show the prime number, all of the prime numbers. This is called generation. Or output our top 10 customers by total purchase. Again, it's showing or generating. Computers are best at solving problems for which an efficient, applicable algorithm is known. The solution will involve repeated operations on input digital data. So here he's stressing that it should be digital data, not, I guess we'd say, analog data. So first you'd have to convert it to digital data. Okay, but we won't worry about that now. Okay, programming languages. All right, we'll stop this video and come back to this in the next video.